Now in the course we're going to use some notation that you need to get used to. And this is called function notation for want of a better word. We want to well, it's going to look like this, f of x. Okay, now f starts to stand for the function, but we could use any sort of letter. Again, it's just a symbol. So use any pronumeral like g of x, h of x, just depends on what it was. Basically, instead of y, we're using the fx. And now it has a little bit of advantage of instead of writing y is equal to 3x minus 6. Only for the simple fact that we could start to sub numbers in without having to say let x be equal to 3 or 7 or y. And so we can do that. So when we have the function of x is defined as that, basically we're saying we've got some function defined in terms of x. So the pronumeral you see there, you should be seeing there. And basically when we do that, if we substitute x with another number, so putting 3 in for x, the x here gets substituted as well with that number. So you notice the 3x plus 6, when we substitute 3 goes 3, when it substitutes 7 becomes 7, substitute y becomes y. Or even if we substitute x minus 1, we get 3 lots of x minus 1. So the x becomes x minus 1 because that's what we're substituting. Minus 6, and then we simplify. That's what we're looking to do with this notation. And it's just another way to be able to write it, but it makes life a little bit easier when we want to communicate what's happening and write down some of the functions that we're going to do in the course and some of the problems. It makes life easier for us. So let's see how we apply it with other ones as well. Function of x is x plus 3. So find the function of 1, function minus 3. Sub in 1, so 1 plus 3 is 4. Sub in minus 3. Minus 3 plus 3 is 0. So that's what we're getting there. Find the value of the function of 0 plus the function of minus 2 if the function of x is x to the power of 4 minus x squared plus 1. So the function of 0, so there's the substitute of 0. So 0 to the power of 4 minus 0 squared, well that doesn't change, plus 1. Plus the function of minus 2. So we substitute minus 2 to the power of 4, minus 2 to the power of 2, plus 1. Again, be careful with your signs, and that will calculate to give us 10. So then question 3 here, function of x, there's our definition of our function, 5 minus x squared. Function of minus 2, we sub it in and calculate. Function of 3, we sub it in, we calculate. So again, we're just being careful of what we do. There should be a minus there, so let's be careful with that. So it should be minus 4. This time we're using g of x. It's just a pronumeral. So g of x, f of x, h of x, it's really the same thing. But what we're saying is the function g of x is defined as 2x minus 1. Now this is a little bit different because what we want to do is find the value of x if the whole thing's equal to 5. So what value could I put in for x that when you sub in there gives you 5? So g of x is equal to 5. So I substitute g of x being equal to 5. And then solve for x gives us x is equal to 3. So if we put x in there, we get 2 times 3 minus 1 gives us 5. Yep, that would be right. So just a different play on what we're doing there. This one here is what we call a piecemeal function. We mentioned that in the last video. Now what a piecemeal function is basically the idea that for different values of x, different domains of x, we get to use different functions. So when x is greater than 1, we're going to use the definition of the function as being x squared, a parabola. If x is less than or equal to 1, then we use the definition of 3x equal plus 4, a straight line. So what we've got to look at first when we do these is look at our values that we're substituting in. So in the first one here, the function of 0, 0 is less than or equal to 1. So we're going to use this function. So there's what we use 3 times 0 plus 4. Substitute the 0 in. We use function of 0. In the second one, it's the function of 4. Now the function of 4 is actually greater than 1. So if 4 is greater than 1, we use x squared. So that's why I'm going to put in 4 to the power of 2. Because I've got to use this function because 4 is in that domain. Minus 2 is in this domain. So that's why we have the second function. 3 times minus 2, which x is minus 2, plus the 4. And doing our calculations, that gives us 3 times minus 2 plus 4, and we get our calculations correct. That should be minus 2. So let's be careful about that. and then the function of 1. Well, 1 here is right on the boundary, but 1 is actually part of this one because it's x is less than or equal to 1. Remembering inequality signs, the function of minus 1 would be 3 times minus 1 times 1 plus 4 gives us 7. So the function of 1, we sub in 1, and we're using this equation doing our calculation. So that's what we do with what we call a piecemeal function there. So the next one, let's have a look at another piecemeal function. And the idea of this piecemeal function again is this time we've got 3 different domains that we've got to use. So if x is greater than 2, we're going to use that cubic equation. If x is equal to 2 or equal to minus 1 or any number in between, we're going to use line y is equal to 2x. And if x is less than or equal to minus 1, then it's going to be equal to 5. So function of minus 17 is equal to 5. So what we've got to do is work out the function of minus 3. Now, if we look at the function of minus 3, it falls into that category. Minus 3 is less than minus 1. So the function of minus 3 would just be equal to 5. The function of 0, well, where does 0 fall? 0 falls between minus 1 and 2. So we're using this function here. So that would be 2 times 0. Function of 4. Function of 4 is 4 is greater than 2. So if x is greater than 2, we're using x cubed plus 1. So we'd have 4 cubed plus 1. So that's where we get that one from. And the function of 2. Now 2 is right on the cusp there, but it's equal to 2 in this part. So when we want to do that, we're going to use 2x. So the function we're going to use will be 2 times 2. Now there's our 4 parts, and there's where we start to put it together. There's the function of minus 3, the function of 0 that we saw, minus the function of 4. So there's minus, so that's why I put it all in brackets, minus the whole thing. So minus that whole thing. And then 2 times 2 at the end. Doing that calculation will come out to minus 56, because that would give you minus 64 minus 65 plus 4 plus 5. So minus 65 plus 9 gives us minus 56. So there's a good example of our piecemeal function, because there's 3 different domains. And when we do this, that should cover every value of x. Just because if you've got some values of x not represented, well, that won't work, because every x value of x should have some sort of function related to it. So get used to this notation. As I said, we're going to see it more as we go through the course. And what does it mean? Basically, we define a function in terms of x, and then when we do we can do a substitution to get a particular value in at a particular time.